Hi, my name is Edward Gouilliard, and I'm with Harper Schwab, and we are working on the CAR project, which is short for Center for Investigative Reporting, and the title is Publicization of OSHA Data. So who are we? We are working with Melissa Lewis, who's the data reporter for Reveal News, which is the company that we're working for. Nick Ross is our data science clinic director. I am a fourth-year undergraduate data science major, and Harper is a third-year undergraduate data science and human rights major.
A bit more background on the project that we're working on. Again, we're working with Reveal News. And what Reveal News wants to do is to display previously confidential company data of illnesses and injuries that was kept by the government, and then display this publicly on their website. And they got access to this data by suing the government through the Freedom of Information Act. And as you can see, the judge sided with Reveal, making all of the OSHA industry illness and injury data public. And further on the project, we have this data downloaded from the census website now through OSHA. It contains yearly reports of the injury and illness rate for all these companies. And our job is to clean and publicly make this data displayable on the website. And the biggest problem of this data is that the employer fills out the information, which, as you'll see later, leads to many issues with the accuracy of the information and also how we can link it together with other industry-level information to create a robust data set. The target of the project this quarter was to improve the data pipeline from the raw data all the way to the clean data, again, so it can be displayed on the website. Success of this looks pretty simple. It's that all companies have accurate organizational data and industry data that's matched together and displayed on the website. Some of these organizations already do, and we just need to fill in the gaps. An example of this is if the Data Science Institute had the data on our platform. The Data Science Institute in this example has the company illnesses for a given year as 10. That data is from OSHA. It is for the Data Science Institute itself. However, the Bureau of Labor Statistics has industry illness rates of, let's say, 2. And that would be not for just the UChicago Data Science Institute, but other similar organizations from universities across the country. And that, in this case, would mean that the Data Science Institute has a greater rate of illnesses than its industry average and could propose some data journalists to look at the Data Science Institute for future articles. And we'll talk about this later, but we've connected the OSHA data and the industry-level BLS data with what we're calling a cloud map.
So the project goal is to display company and industry data. The most important data that is going to be public is the company's injuries, illnesses, days away from work for each employee, and the medical treatment. The highest injury rates do not necessarily designate the most dangerous workplaces. Some companies systematically underreport injuries or pressure workers to avoid getting treatment. So low injury rate may be misleading, and a high one may still be undercount. A workplace could have low injury rates but multiple deaths, and some companies fail to report it at all because companies are the ones who file their reports on their own. So not all companies are reflected on the public website. Only work sites with 250 or more employees are shown, and those of high-risk industries with 20 or more employees are required to report the injury data. On the website, if you look up, for example, Amazon, you'll see two graphs: one injury rate and another which is the serious injury rate. You can also compare the injury rates to the BLS data. You can have a table and see the differences. If you want to download the data and do your own analysis, you can download the data on the website. So the project importance is to ensure accuracy of the injury information. So we have to clean the data from the raw to make it good for the public website. We have to make sure corporate and governmental transparency, and we're supporting support for data journalists in Reveal News and other journals.
So how does this data cleaning look like, and what are the main issues? We need a robust data pipeline with both the OSHA data, which is, again, the company singular yearly data, and the BLS, which is the industry average. The main issues with this is record linkage, and mostly through the NAICS codes. The NAICS codes are a hierarchical code which essentially classifies an industry up to 6 digits, which is the most granular, down to 2, which is the least. For instance, a 6-digit code could be for tin fish and other fishing equipment manufacturing, whereas 2 digits could just be manufacturing. The main issue with this is that there are changing regulations between OSHA and BLS for how these codes are implemented. Every 5 years, starting from 2002, NAICS codes were started, and they essentially are able to split or merge into different codes depending on the needs of the industries throughout the years. For instance, the BLS may change every 5 years for how the NAICS codes are regulated, meaning that a new NAICS code is used every time the codes change. Whereas OSHA could be changing on a lag, where in 2005, let's say, they start using the codes from 2002, whereas in 2010, they'll start using the codes from 2007, but the BLS may change every single time, meaning that when a user inputs this data to the government, it is hard to tell which code and which regulation they're using. And what we did is started a mapping for these codes, meaning that for each of the potential codes throughout the years 2002 all the way up to 2022, we can find out which NAICS codes have changed, merged, or split. And we've done this by creating a cloud map. The cloud map contains every possible code that has changed throughout the years. So the codes 336992, which corresponds to the industry military armored vehicle tank and tank components, could change into 336993, and then eventually could merge with another code, let's say 336994, back to, let's say, 336993. So you can get this complex web, what we're calling, again, a cloud map, which then allows us to link NAICS codes from the BLS data to the OSHA data and hopefully create a fully filled out data set.
So if we look at an example in the table below, you have the red and the blue line, which are two very simple cloud maps, where in 2012, there was a change in the NAICS codes. So that's why we can see the link. We can also see above that in the turquoise line, there was in 2012 and 2017, there was a change in the NAICS code. So this is the whole point of the cloud map. The cloud map is to create these links between the NAICS codes throughout the years, so that we can keep track of them. We can also see make a map between the OSHA and the BLS data to include it in the cloud map. Another problem that we had was in the geocoding pipeline. So we had to improve the pipeline, because previously what we had is we had a geocoder which we had downloaded from the government website, and we applied it to the raw data and found that many null values came up. And that was a big problem, because going on forwards in the pipeline, it would cause many problems. So we started to look for different geocoders. We found the Bing Maps API was a very good one and cheap. So we implemented that one and found that there were basically no null values. The downside is it did take 2 days to get all of the raw addresses into clean ones. However, now that we have a cache and we have the addresses already, we can just integrate into the pipeline and it will run very quickly.
The next steps for the project as a whole, again, is implementing the NAICS and BLS mapping into the pipeline, as well as the geocoding. This allows us to fill out the data set that we currently have to create less null values and essentially map out both the company and the industry level injury and illness data. We need to ensure that there's proper implementation of this new data on the website visualizations, so it can actually be used by data journalists. And also, with any new change, we need to check for further missing data and also look to how we can improve this data pipeline further.